the entire U.S. Since the middle of 2010, I've been working for REC. I'm extremely happy to be doing that same thing today. An excellent company with excellent products. It takes great care of its customers and its employees. I think all those things are quite important. My colleague George McClellan is also on the line. Would you like to offer a brief introduction?
Yeah, good morning. This is George McClellan. I'm Technical Sales Manager. I'm also been in the industry for quite a while. Been with REC for about 8 years now. And I'll echo Chris's comments. It's a great company to work for. We feel we have a very good product and pride ourselves on our customer service. I'm in California on California time, so if you ever have any questions, comments, need any information, please keep my email and number handy. If my phone's on, I'll pick it up. And you can ask anyone who has worked with me. It's pretty much on all the time. So look forward to making your customer experience wonderful. I'll turn it over to Chris.
Excellent. Thanks so much, George. And I can vouch for his availability. We've worked side by side for the last 7 years, literally. And certainly day or night, he always pays attention to what's important. So thank you, George, for that. And thank you in the audience for carving out a video or Friday to spend some time with us. I'm going to do my best to keep this concise. My general preferred presentation style is I'm not going to read the words that are on the screen because that's the screen on your own computer you can look at, but really rather deliver the narrative of how you can use this information to be more successful in your business. So whether your own responsibilities are directly selling within your organization or not, what we'd like to do is really empower anyone who is working with the REC product with in essence, a quiver of arrows. There's lots of information that's all very good about the value proposition of REC product and then the company standing behind it, but not everything should be talked about in every single instance with an end customer. So the key is really understanding what's going to be important to that end customer and picking out the 2 or 3 elements that will really hit home and really create value, really enable for a shorter business cycle for higher close ratios, and really achieve that business advantage there. So that's what we're going to be focusing on here today. The webinar format tends to be most effective, as Hannah alluded to, when the interactive portion, meaning the question and answers and discussion, comes at the end rather than the middle. So that's a little bit different than in an in-person presentation. But overall, a lot of experience in doing this here with both organizations. We've been proud to have AEE as by far our largest and most important distributor, literally since 2008, and we've grown that partnership every single year since then, and very happy with that track that we're on. So without further ado, the actual presentation here, as the agenda shows on the screen, really just 3 basic elements that make a ton of sense sequentially, which is broadly what makes REC different as a company and the products that we're making. The second piece of that, how do these products deliver value? These 3 key elements that we really have focused on for literally 20 years of experience in this industry, in direct participation up the entire value chain, and we'll talk in just a sec about what that means. But really our focus as a company is performance, reliability, and durability, so that we can be that reputable brand, the brand that you can trust, so that there are no concerns over the product, over the business relationship, over any elements. There's enough in this wacky solar industry to need your attention. We want to be the piece that is reliable. And certainly the last piece to tie it all together is some real life examples of, well, the story is great. As we peel back the layers of that onion, every single thing you've learned sounds really fantastic, but where is the proof in the pudding? Where does the rubber meet the road? What sort of folks and projects have used our product and been extremely satisfied in the years since REC has been active in the U.S.? The details of REC and who we are really traces back quite a bit longer than most companies that are active in the market now. REC dates back to a Norwegian origin back in the mid-1990s. This was actually a focus originally in wafers and cells, which was really the most difficult piece to manufacture back 20 years ago. And just as a case in point, the Norwegians who started REC developed such a competency in advanced wafer processing techniques and going literally from washing some of these wafers by hand to developing fully automated processes and the quality of their product. Again, these wafers and cells were never branded to the end market because the customer buys a solar panel, not just a cell or a wafer. But highly regarded companies of that era, such as Mitsubishi Electric, was among our largest customers. And REC went through a transition period where, again, always being very industrial in culture and being very focused on excellence in manufacturing, quality manufacturing systems, really just how do you make a good product is focused around process stability, traceability, so that you know what you're making and you know what worked well and what didn't. And consistently through time, you make improvements based off of what's working better. That's not an earth-shattering revelation. There's companies like Toyota under the Toyota production system that have been doing that for quite a long time. That's how they developed their reputation for quality. It's no accident that our internal REC business system, called RBS, looks very similar to those best manufacturing practices as you would see at Toyota. This is something that we've taken very seriously for 20 years. We are still to this day active throughout this entire value chain you see on your screen from left to right, meaning we're making our own silicon in Norway. We are making our own ingots, wafers, cells, solar panels in our own factory in Singapore, which we built in 2009, commissioned the beginning of 2010, and certainly have a lot of experience with our own facility, having debottlenecked and optimized everything through time. So really, the key of this slide that I would leave you with is how REC is different than other current players in the marketplace is a depth of experience both up the entire solar value chain and also in the amount of time, the amount of experience that our team has in developing best practices that really I think is unparalleled. We have had to morph and change with the times. REC as a European entity was actually the first to realize that we needed an Asian cost structure to compete in the solar market of the future. REC realized that as long ago as 2007 and 2008, very significant planning exercises, 2009 site selection in Singapore, and really we've been extremely happy with the result of what we did, and can really thank the executives of the company for having a lot of foresight at that time. The next slide that we're showing here, and again, the key theme here is that what you can expect from REC is reliability. That's not just a product attribute, although that piece is very important. It's also in how we are running our business. The solar industry globally, and certainly in the US, has grown exponentially. It doesn't mean that profits were always easy to make. The manufacturing piece, especially of this, is quite interesting because overall margins tend to be quite low, but it's very capital intensive. The factories up this entire value chain, not just a module factory, it's cell factory, the wafer factory, the silicon factory, all takes a lot of money, and you're either using debt or equity, but you have to convince someone that it's a good choice to mobilize that money to build whatever factory assets that you're building. The risk there is that you spend a lot of money on factory expansions and become the next 3, 4, 5, 7, 10 gigawatt player. But how is that going to make business sense in the long run? No one in this industry can really afford to be a volunteer, and ultimately companies that take on too high of a debt load, even if they're very large and have some sort of unique way of going to the market, whether you're, say, Suntech from years ago or Yingli most recently, those were the largest manufacturers at the time, and that was not a good thing. It's probably not also the best thing to be tiny because then your scale is somewhat irrelevant. You don't have enough money to spend on R&D and actually have competitive products. We feel that REC has really the best balance. We have been following our own course, if you will. These charts that are on the screen shows comparatively, and this is a linear scale. So it is comparative. If you look at top left at the debt position of REC, how much debt we've taken to grow and run our business versus those other recognized names, tremendously less. What does that mean? Very practically, it means our expense related to that debt is lower. It means that as a company, we don't have the financial pressure and stress of trying to service that debt, pay it down. Those were the things that created very negative situations with some other manufacturers that got too large. So what are we doing within this? That bottom chart, which is showing warranty returns. I think the industry as a whole has done a great job of really crystallizing best practices around a reliable product for the end consumer demographic. If there were a ton of failures happening left and right and fires and et cetera, that would be a black eye for all of us. It's not a positive thing. So clearly that's not happening, but behind the scenes, there certainly is quite a bit of a difference in warranty claim rates, for example, between manufacturers. The very tiny yellow bar at the bottom chart is REC. This is warranty returns in parts per million. Really, we're talking about such a low percentage, 0028, 0046. These are things that really speak to the effectiveness of the REC quality management system. Other folks that are certainly reputable names in the industry have claims rates that are much higher. So again, just one thing we can look at and indicative of REC's approach in how we view this industry, how we view customer and product commitments, and we take that 25+ year lifetime extremely seriously.
Hey, Chris, if I could just jump in for just a second. So that 28
Please.
Parts per million there, just by comparison, just to give you an idea of what that really does mean, that's about one module per every 5 megawatts of installed modules is failing. So we aren't saying that our modules are perfect. We're just saying the failure rate's really, really low. So about one out of 5 megawatts is going to have a problem. So just FYI,
George, for
if
that.
anyone's asking me about that, yeah.
Now that's an excellent way to contextualize what this means. And George, do you have direct experience with this, or are you just looking at numbers with respect to?
Yeah, absolutely. So that's the good part about all of this. I am the warranty claims department for the United States. Been doing this for about 8 years now, and it doesn't keep me very busy. That's about one claim every quarter comes in, and a lot of those are shipping damage and things like that that really aren't related to module failure rate. With respect to in-field failure rate, the rate is just incredibly low.
Excellent. Thank you, George, for that. And I think we'll loop back down to some greater level of detail around that in a few slides. But certainly part of REC's long-term commitment to our customers, to the end customers that have the delivered PV system, is we want to be around to service the warranty, whether you need us year 1, again, highly unlikely by the numbers, year 25. But regardless, we want to be that reliable entity that is around for the long run, not a flash in the pan that's here with a attractive offering one day and out in 2 years. We've certainly seen that in the past. It's a challenging environment for manufacturers to maintain a stable balance sheet and really prepare financially for the long run. That's what this slide, this is the Altman Z-score, which if you want to see what the actual equation looks like, this dates back to the late 60s. There was a professor named Edward Altman. But this is basically the most highly regarded formula in the business world as a predictor of bankruptcy. And there's thresholds here. Again, that top tier, low risk of bankruptcy, something that you might want to be careful of below that, and then a high risk below that. Well, as you might guess, in the solar industry as compared to, say, a more mature industry with longer tenured players, no one here is the same size as General Electric, for example. But you would expect for, say, Yingli on the far right to have a very pressured financial position. We all know that. It's made headlines. And that's what you see reflected here. That's the numbers certainly speak to that. There's other folks that are flirting with the dangerous area. REC, again, conservative, low risk, reliable. You would expect us to see a very good placement here relative to our peers. And and that is indeed the case. A natural follow-on question on this next screen here is, well, okay, I'm starting to understand who REC is, what you've done. You've built an amazing factory that's automated in Singapore. That's not the cheapest place, probably not as cheap as if you build a factory in China or in Malaysia, which is right next door to Singapore. Singapore is an ex-British colony. It's really let's say the Western hub into Asia, a very stable political and economic environment, but more importantly, a lot of access to high quality people. And those are the folks that are really running our factory and creating these products. But do we acknowledge that the cost of our production, while competitive globally, is it going to be a bit higher than others? Yes, it will. That's the largest bar on this chart. That's sort of our yellow versus the blue on the right. And this is an anonymized, pick any of, say, the large 6 competitors that we would have globally. But I think analysts unfairly pay too much attention to just cash cost of production, because as you well know from running your own businesses, it's not just about job cost and the gross margin on a job. You've also got overhead and other expenses in your business. And if you expect to be healthy in the long run, you need to account for things like SG&A and debt expense and depreciation and maybe even making a positive margin. Otherwise, there's not a lot of reason to continue. So if you look at the stacking of those factors, we proportionally spend less on those other items, whether it's the debt expense we talked about before, because we're not the company that is sort of like a person running around with maxed out credit cards. We're the very opposite. We're the person running around with 3 credit cards that have almost no balance on them. But we have excellent credit, so we have the ability to secure that debt, but don't think that's a rational thing to do. But we are also not the company that's spending a ton of money to have a U.S. Team that's 40, 50 people. There's literally, for most of our history, there's been between 4 and 10 of us. We're also not the folks that are sponsoring World Cup teams, as fun as that is, or Formula One, which is amazing, but the return on that sort of investment just isn't rational. It's not sensible. It doesn't add value to our customers or to the end customer. So again, we are the rational company who is saving money there so that the overall package, this is how we are competitive literally against anyone in the world. We're not cutting corners to get there. The next slide here, the correlation between what we just talked about is where do we spend money in our business? Clearly, it's in excellence in manufacturing, and we've also pushed the envelope as far as product design, really in our history pushing the multi-crystalline platform further than anyone else. That's the embedded chart on the top right is our R&D expenditures as a percentage of revenue. We actually spend a lot of our money on R&D because that creates tangible value. George, I think this is a chart that you're a big fan of. It shows sort of where we've been, where we're going, and how we view the different types of products we make.
Yeah, absolutely. So the products here, you can see we've got pretty much 2 different styles of product. We have a residential, smaller 60 cell module style of module, and then we have the 72, which is more of a utility scale or commercial industrial type product. The watt classes are we're in the low the 300 range for the 60 cell modules with the new TwinPeak product, and at the TwinPeak 2 product. The 72 cell module is coming in at between 340 and 350 watts, which gives you an excellent power density ratio for crowded rooftops on C&I spaces. One of the things I'm going to show you on the right side of this is the new TwinPeak 2. We have a new black module, which I believe that we'll be looking at later on in this presentation. But we feel we've got the space fairly well covered with good, high quality and available products here in the U.S.
That's right, George. Thank you for that. And as you say, we're quite excited about the new all-black product. We'll take a look at a real-life picture in just a few slides here. But the bulk of the business that we do with AEE and AEE dealers is really around the 60 cell that is sort of the de facto choice for residential, but at a 1,000-volt UL rating. It can also be used in small commercial, although larger projects do tend to prefer our 72 cell. And we have a great pattern of working with AEE in the last year on drop ship requests. So we maintain our own warehouses, one on the East Coast, one on the West Coast, and we're able to mobilize 72 cell shipments directly to the site. And the TSMs at AEE have been fantastic about queuing up that sort of business. And just off the cuff, I ran the numbers a bit earlier, and then we had a larger project. I want to say it's been close to 5 megawatts just this year of 72 cell product, which again is not even the normal stocking inventory, but it's something that's had a great reception amongst AE dealers, and really suggest to take a close look at that. Speaking of close look, there's just a couple slides here that trace the results of what REC has been focusing on with our product development in the last, say, 4 to 7 years. This is the standard format 60 cell module. Back in 2009, 2010, a lot of these in the industry were somewhere around 230 watts, pushing towards 240. And in the years after that, some incremental advancements, whether it's cell texturing and anti-reflective treatments and different shapes and sides of the bus bars, that basic format was able to be pushed all the way to 260 watts, but really sort of hard to get beyond there. So then you'll, well, if greater power densities add value to the market, how do we get there? One choice clearly is go to a monocrystalline architecture. There's some challenges there with respect to the light-induced degradation. We'll see a chart on that. But basically, the multi-crystalline value chain, where we have a deep experience over 20 years, has been optimized in such a way that it is extremely reliable. We know we can get out of it in the long term. We've optimized it for high temperature performance, for other things that are very relevant in the field that we'll see a breakout on later. But our innovation that was launched in the market in the beginning of 2015, we were the first to commercialize multi-crystalline PERC cells. PERC, of course, is now all the rage. We had been R&Ding that for years before we introduced it. And there was a reason why we were able to take that particular technology and also take another leap with half-cut cells at the same time and really make that work in a highly reliable product that had zero issues, even though it was a leap for the time. So that enabled our advancement to the 270, 280 watt class, again, same size. The most recent innovation is a further advancement of that same platform. That's the TwinPeak 2 60 cell module, which right now is mainly 290 watts on a white backsheet. If we go to a black backsheet, we're going to lose a little bit of that power, probably end up around 280. But again, I would say this is the bread and butter of the business that we do globally and through AE here in the US. This is a tremendous module with a lot of really favorable characteristics that go beyond just what you see on the data sheet. And George, if there's any notes you want to mention on the 60 cell line before we move on, that'd be fantastic.
Yeah, one of the things that we do want to point out, is Chris alluded to, is the use of PERC cells. We were one of the pioneers in that. There's a lot of companies that are coming out with a PERC product right now, trying to jump on the bandwagon of getting a few extra watts out of that package. PERC is devilishly difficult to master. You can demonstrate it, and you can even do it in a lab, and you can do small production. But when you're doing 4 million cells a year of this product, it becomes very difficult to get high yield numbers, and that's something that REC has mastered. So you may see this, you may see other companies saying that they do have PERC product, but keep an eye on those yield numbers and really what is available. They may be displaying something, but really not shipping high volumes of that product.
That's right. I'm glad you mentioned that, George. And by the way, we've been involved in this PERC processing, which the general industry term, and we're an industry that loves our acronyms, but it used to be called BSP, backside passivation. That was before anyone coined the term PERC really just came out in the last 2.5 years. It stands for passivated emitter rear cell, but basically we were doing PERC before PERC was cool, if you will. But it's because we were not following a bandwagon. We saw this as a fundamental backside of cell advancement. And again, with our investment in R&D, we are always looking to optimize anything in the entire value chain we control, from silicon all the way through the module. And this is a clear example of that. Just a quick story: you have to be very careful with how you execute this PERC treatment, and paying attention to things like boundary layers, and then the chemistry within these materials that are sitting next to each other, or you can result in negative characteristics such as significant light-induced degradation. This was actually a hot topic as recently as a year ago that, oh wow, from some folks who don't have the right processes and the right process control for PERC, you could see LID of potentially 3, 4, 5% right off the bat, which takes away clearly all the advantage of even doing that in the first place. REC has independently validated, this is third-party test results from DNVGL, showing an average of 0.8% LID. So again, everything we're saying, it's not just that we only believe it, because from being with REC so long, we do believe that we fundamentally have an edge and have an advantage over others, but that third-party proof and corroboration is certainly there. So I think we spent enough time here on the 60-cell product. There's basically a very parallel advancement for the 72-cell. 72-cell, of course, is just larger. It's the same basic design, materials, construction. The fundamental difference about point here, you're basically seeing the same migration from the 310, 320 at the left to the 335, 340. That parallels what we just saw in the 60-cell, right? And if you do the math on the power densities, that's basically the same thing for the same reason. Where it starts to get more interesting is in the larger project space, we have the opportunity to really pursue some unique advancements and look for ways to add value as a whole. And that's what we're seeing with this new product. Literally, the TwinPeak 2S72 just began production several weeks ago. So we're bumping up into power classes that are above 340 watts, again, on a multi-crystalline platform. This is half-cut cell, multi-PERC. This new product, we're taking full advantage of all the latest design elements to really capture that value for today's cutting-edge commercial and utility designs. And what I mean by this is a 1500 volt UL bill of materials standard. We are going to a thinner frame at 30 millimeters, but adding support bars, so it's actually stronger than the thicker frame we had before, but we dropped a heck of a lot of weight. So when you go to a thinner frame, plus support bars, slightly thinner glass, we're improving the performance of the module because the cells stay cooler. There's less loss of the light going in through the glass, so better light transmittance. We just dropped a bunch of weight, going from a bit over 60 pounds to under 50 pounds, which is meaningful for the guys that are carrying these things around. And we're extremely proud of this. This is, again, a new product for us where our pre-sales started just a couple months ago, and the bookings have just been fantastic. This is personally one of the two things that I'm most excited about product-wise at the moment. George, am I missing anything before we move on?
Yeah, so one of the things that is also, and it's the small things that start to really add up, with this product is actually on a thinner frame, a 30 millimeter frame. You're actually able to stack 31 modules per pallet as opposed to 25. So now your packing density gets better. The warehouses like this better. They can put more modules on their shelves. We can ship more modules per container. So logistics now becomes a little less, you've got a little bit more efficient logistics and packing density for this product as well. So that's, and like I said, it's the little things that really start to add up to the installers, to the warehouse managers, things along those lines.
Absolutely, George. Thanks for not letting me forget that. So we're clearly the ones that are using container shipments, but that same packing density, when it gets to a warehouse, it means that it takes less of a footprint within the warehouse. It means that when it gets loaded into a truck and goes to a job site or is stacked around a job site, it takes up less room. Really, there's advantages all the way down the value chain for that, and that's something that's a clear example of how REC thinks holistically, and we want value-added solutions that are reliable. So moving on from that, I mentioned that that new 72 cell product is one of two things that I'm very excited about, but this is the second. This is an all-black REC TwinPeak product, so it has the same characteristics we talked about 2 slides back. This is a multi-crystalline half-cut cell, but it has a unique reactive ion etch on the front side. So that's a little bit more light capture. It improves the efficiency by a little bit, but gives it a very nice all-black aesthetic that everyone who I've personally shown this, and I'm deliberately showing not a studio shot here. This isn't a marketing shot. This is me taking a module and putting it in front of my house and taking a picture with my iPhone. And so this is really what it looks like. Most folks think that it is mono because it looks exactly the same. This is something that we're extremely proud about and is finally available in the US as of now. That really culminates our first section here, which is who is REC? Why are we different? What are the products that I can expect purchasing through AEE? And then this next section really, we won't do a deep technical dive. We'll save that for specific questions that may come up at the end. So this will go by fairly quickly, but we're going to rely on George a lot. Again, George's background quite deep in this industry with not just one manufacturer. So he understands different ways of doing things and how it manifests in real life in terms of both product performance and mitigation of failures. So the intro into that is, well, let's talk a bit about a detail of what makes our architecture fundamentally different, and then we'll look at some of the other values and value-added parts of the product that can really constitute value for the end customer and the delivered system. So George, again, this is going to be more your section than mine. Please go ahead.
Yeah, good morning. Okay, so one of the advantages of the TwinPeak architecture is that it has 2 individual matrices of cells that are paralleled in the middle of the module. So we've got 60 cells in series, 2 sets of 60 cells that are in series with bypass diodes running through the center of the panel. So what that helps out in is in shading performance. You can see the diagram on the drawings on the right-hand side of the slide here. A standard panel, if you shade the bottom cells, you end up, the bypass diodes will go into bypass mode, and you will lose the current from that module. You'll be developing no current from that module, so you'll lose that module out of the string. With the TwinPeak module, you can see on the bottom part of that drawing, the diodes are in the center of the module, so you would only lose half of that module. So the bypass diodes would go into effect and take the bottom string, the bottom matrix of cells out, but it'd still leave 50% of the module working at full capacity. And you might, you may be thinking, well, George, I don't have shade on my modules. But if you think about modules installed in portrait, and if they have soiling on them, you know where the soiling is going to build up, and sooner or later that soiling is going to build up enough to cause the bottom cells to be shaded, and you will lose that module. So this is a good example of that. Also, if you're installing on rooftops in portrait, you can increase your packing density, get a better ground coverage ratio with this, because you can pull your modules in a little bit closer. Your intra-module shading is not going to be as damaging, so you may be able to get that extra row of modules up on the rooftop, increasing your packing density. So this is one of the real keys of the shading advantage is one of the keys of the TwinPeak series. Anything else on that, Chris, that I missed?
I just wanted to underscore, that was a fantastic explanation, and it's key to understand that in a traditional module, basically what you would get from anyone else, there is that bypass diode protection and shading across the long side, but not the short side. So any amount of shading up from the short side can kill the entire module's output very quickly. And this really comes into play, I'd say, most significantly in 2 segments. One is not so common for AE dealers to be participating in, which is utility installations on single-axis trackers. But basically, you're able to turn off a backtracking functionality. We can talk offline if any of you on this webinar are involved in single-axis tracker installations. There's some very specific ways to maximize yield there to take advantage of this. But in residential, I'd say residential systems potentially have the greatest exposure to shading of anything, because the layouts available on most people's roofs, I mean, there's trees, there's vent pipes, there's some amount of shading is unavoidable in most instances. And this is really a way to mitigate that. And a classic example of, well, what is an advantage that I don't really see on the data sheet? That's not something that you can see modeled at standard test conditions, but is absolutely a key component of real-life performance day in and day out for decades. This is it, and this is why REC had put so much intellectual horsepower and R&D behind this. So I think these next few slides, George, will go a little bit more quickly because it gets into some granular numbers that I think for the webinar attendees will be useful later to look over in more detail. This presentation will be distributed to them, but maybe if we could just spend 30 seconds for you to talk about what this means as we go through.
Yeah. Okay. So LID is it's a common effect. We all multicrystalline and polycrystalline modules are affected by LID. Our processes, again, this comes back to being vertically integrated and controlling our manufacturing all the way back to the source silicon. By doing that, we were able to control LID, and our LID has been some of the lowest in the industry. We're typically seeing about 0.8% LID, and this has been validated not just internally, but by third parties and internal testing. But yeah, take a look at these numbers, and if you have any more questions on it, you can get back with us, with myself or Chris offline. Next slide.
Absolutely, and I would just echo that the key there is that none of these attributes are by accident. So two things that I'm a very big believer in is, first of all, if you think your product or service is better, you should be able to explain why that is. So again, that was the first part of the presentation. It's our depth of experience and participation in controlling the entire value chain for 20 years. That is why this exists. So we know that. And then also, second, can you prove it? Granted, with our REC hat on, George and I are not impartial. We work for this company, but we do wholeheartedly believe in our offering. And I've got 10 kW REC modules on my own roof. We've been there for years. But independent third parties that will vouch for this, such as independent engineers, DNVGL, Black & Veatch, et cetera. We have all the supporting data. If there's a particular end customer or a financier or a situation where we really need to get into the details and prove out why this is reliable information and can be counted on, we've got all that.
So then the second part is the actual degradation of the modules. We do a lot of work on understanding what our annual degradation is and what that looks like over time. So we have a lot of modules in the field that we actually will go out and do year after year testing. We have some that have been in the field actually almost up to 6 years. And you can see that our average annual degradation rate is coming in at about a little under 0.5% per year, and that's factoring in LID. So this is something that is actually, if you look at it without LID, this number would be significantly less than that 0.48% degradation per year. And this is something, this is real, this isn't cherry picking modules. This is going out and selecting a full string of modules at a site. We've got a site up in Northern California. We've got a couple in Colorado that and one in Florida that we just pulled modules from. We'll pull a string of modules from, send those back to the factory for test, and replace those other ones with new modules. So it's worked out very well with getting good, consistent numbers and being able to track things year after year. Any questions on degradation?
No, George, I think you've got it, and we'll sort of aggregate all the questions for the end here. And I think there's just a couple more slides on this, quantified aspects of the product performance and the reliability. And this, I think, is an excellent one, looking at the temperature-related performance.
Yeah, so what we've got here is we've graphed out the temperature coefficients of the REC module and then another typical multi-crystalline module. And you can see that the module efficiency, we all know that module efficiency goes down as the temperature goes up from STC. So this is basically the graph of module performance as the module temperature goes up above 100 degrees. And you can see, and the module spends a lot of time up above 100 degrees. I think we all know that. You can see that the REC temperature coefficient, which is 0.36% per degree above STC, you can see that the degradation is lower, or the drop-off is actually a lower rate than a typical multi-crystalline module. And that really starts to, you get another, almost a full percentage point where the energy yield, where the modules are spending a lot of time, most of their time during any of the summer and sunny months. So this is, and this isn't, conceptual. This is the physics behind it all. Modules, and we know these temperature coefficients are validated.
That's right. I would just make a brief observation that when we see the temperature scale on the bottom, this is the operating temperature of the module, of the cell itself, which is quite a bit hotter than ambient. So it's not the case that, oh, well, on a hot day, I'm not seeing 110 degrees. If you've ever touched a module on even a moderately sunny, warm day, it's quite a bit higher than ambient. So this is extremely relevant to real-life performance. And again, something that is more than just what you see on the data sheet. This is optimized for long-term performance and reliability.
And this is one of my favorite slides. This shows the REC production facility. This shows the actual stringing and tabbing of cells. On the top is the REC that's actually done by it's fully automated. The stringing and tabbing process, big giant KUKA robots that are getting this done with inductively coupled soldering. What you want is to reduce the amount of human interaction when you're doing your assembly. With every bit of human interaction, there is some potential variations. Humans can do a very good job of doing this, but if you look at the lower photograph there, I guarantee you things are doing a little bit different from human to human to human. Robots do it the exact same way every single time. They don't have a bad day. Actually, if they do have a bad day, it's a really bad day, and you know it pretty quickly. So we like to, one of the things I really like to point out when we're looking at these slides, you can look at the top photograph there, and you don't see any people in that. That's the way our factory looks. If you see a person, it's usually someone who's doing some maintenance or someone who's there for documentation or an assist or something along those lines. So this shows this is the reality of what automated production does and what it looks like.
That's right, George. And to echo, it's very impressive in person. I know it's not practical for most AE dealers to fly customers out to Singapore, halfway across the world, and then have them tour, but REC has put together a really, really well-produced video. It's about 4 to 5 minutes. We'll circulate a link with this slide deck afterwards, but it really will allow for folks to see and believe and understand where the excellence in the product comes from. And I remember clearly, I've been to our factory several times, but in the beginning, we took a customer there, and this customer said, wow, this place is gold-plated. And he didn't mean that literally. He didn't mean that it looks like the Trump Tower. What he meant is that it literally is the best of everything, relevant to manufacturing excellence was in our factory. The cleanliness, the automation, the process flow, the efficiency of everything, it was just, bar none, the best he'd ever seen in the other facilities. So that's something that we're extremely proud of as an industrial company who is focused on reliability. George, we covered this warranty thing before, so I think really the element here to focus on, and apologize for taking this away from you, but ultimately warranties cost money if you have to exercise them, because someone has to go out and troubleshoot and diagnose, and there's non-value added time talking to a customer and trying to make them, the end customer, comfortable that everything is fine, it'll be taken care of, and the coordination. So really the net cost is probably more than just the direct costs of rolling a truck and then those man hours. It's a lot of non-value added churn for something that really we feel our customers and end customers shouldn't have to be worried about. That's why we put so much focus on that. Is there anything about that, George?
Nope, that's exactly it. We like to say that the best warranty out there is one that you don't have to use.
Absolutely. George, we've worked with a lot of the most reputable independent engineers in this field. I know Black & Veatch and Dr. Ralph Romero are some of your favorites. Maybe just pick out a couple things from the slide that you think our audience would be really interested in.
Yeah, so we've had Black & Veatch, Clean Energy Associates. There's been just about all of the third-party auditors have come through our site and done a full deep dive audit into that, into the site, and it's at the request of some of our customers and projects. One of the things, so we do have a very good, wonderful automated line, but some of the other things that are interesting that they pick out is things like climate-controlled warehouses for your materials and components, little things like that. Well-organized, well-managed test labs. It goes well beyond the ability to put a good product out. Is not just about a highly qualified manufacturing site. You also have you have to have the value chain supporting that for it to be for the best product to come out.
That's right, George. And I would add just one piece, which is an ex-colleague of mine had done some time in Asia with a electronics manufacturer that were mainly making connectors for all sorts of electrical devices. And he had a lot of experience in the different ways that factories can be set up. And there's this concept, which, well, you could say it exists globally, but certainly a lot of this is in certain higher density of manufacturing areas. But there's this concept of a golden line. And again, just like I had alluded to before, it doesn't mean it's literally golden, but it's basically, it's your one production line that's better than anything else, has the newest equipment, the best manning. The three main elements of input into manufacturing are man, method, and machine. So you take your best of the best, put it all on one line, and that's what you invite your customers and any sort of auditing parties to see. It happens a lot more than you would think, and if you do some research into how long companies have been around, where their manufacturing facilities are, and how they've been built through time, most solar manufacturers have a wide array of different factories from different vintages, different infrastructure, different staffing, different training, different machines, different everything. Really a completely different world from factory to factory. And even within a factory, you have different expansions and different lines that are very different. So of course, you might try to have Black & Veatch come in and only look at your best line and try to achieve comments like this. But when Black & Veatch comes to our facility, again, it is only our own REC facility that we built from the ground up. We've been running for 7 years, and everything is homogeneous. Not only that, it's not just modules in our facility, it's also our ingots and wafers and cells, adjacent, all with the same level of automation and excellence. So when we read through these comments, it's literally referring to everything REC does, not just one thing, one line that looked good once. Moving on from there, George, this is sort of getting more to the commercial elements, and I want to sort of accelerate this so we have some time for questions and be respectful of the timelines of our attendees. But the direct financial impact of not having a bankable entity behind, well, it's not always so easy just to buy a warranty. Warranties aren't free from a third party. but also have elements such as a deductible the manufacturer would have to pay to have that continue to be active. There's typically a cap on these policies, meaning that if there was a serial defect issue and everyone queued up for a claim, they would exhaust the funding. So again, as you said, to use your own words, the best warranty is one you don't have to use. Third-party warranty insurance is not the right way to get there. Certainly from a holistic point of view, this is another way where we add reliability to the value chain. On-time deliveries, again, this is sometimes directly from REC because we have some drop ship business for the 72 cell projects through AEE, so that becomes a very important element. This is a metric we keep very close eye on because we know the negative impact to delayed deliveries and poor communication, which unfortunately happens all too frequently in the industry. We really focus on this in the U.S. because our manufacturing operations are not here, they're elsewhere. What we're focusing on is taking care of our customers, and this is also when we work through distributors such as AEE, who has a tremendous reputation for taking care of their customers. We want to make sure that that experience is something that's felt by the customer and the end customer, because everyone is affected by that. This summary slide, before we just look at a couple pictures that indicate where REC has been installed and what some of the customer feedback has been, this is really the overview of the elements we had talked about, whether it's the bankability and dependable operations of the company, elements related to the product itself, the product performance. These are all things that have varying degrees of value, but as a package, I think make a tremendous case for why REC is different. And again, that's the title of this presentation, the REC difference. And I hope those of you on this webinar have really seen that there is a true difference in the way that this company operates versus others that you might work with. This last piece, very quick here, so we leave time for questions. Well, if REC is so popular and so great, what are some names of folks that have been very happy with our product and service? We see some big box names here. There's a utility cooperative out in the Hawaiian Islands, a couple cities, some Department of Defense entities. Really, this isn't clearly all of our customers, but just an example of the wide range of folks that have been really happy going solar with the assistance of REC. The numbers bear out. This is actually a release from my favorite analyst group, which is Green Tech Media. But as of the end of 2016, we were the most popular residential module in California, which is about 50% of the market. If you take the entire country, number 2, that's a very strong showing. And of course, we are not only supplying modules to the residential segment, we have a balanced business as part of our desire to have a long-standing business that has stability through decades. The project on the far left here is the largest one in the U.S. we supplied. It was 257 megawatts in California Central Valley, literally a delivery schedule that spanned 18 months with specific carve-outs per watt class, per volume, per week. And that was where we achieved actually a better than 96% accuracy and was by far the best that customer had ever seen from a module vendor. Some other similar utility projects here, those are all on single-axis trackers. There are some projects on this page that were commissioned for Department of Defense entities. These are actually owned by a large utility, and the power purchase agreement goes to these entities. These were all in the Southeast. Another sort of overview of just a few unique things, whether it's for a well-recognized brand such as IKEA, what we think is the largest solar system on a private airport in the U.S., which is interesting when you think about it because most airports are actually public. But that's a really interesting installation in San Rafael under a unique feed-in tariff with the local utility. A lot of our modules have gone on to VA hospitals. I want to say a total of probably 15 to 20 megawatts through time, things that we're very proud of. Costco warehouses, some unique programs that spawned in the middle of the country in Indianapolis. There's basically 1 year of a really lucrative feed-in tariff. We have a Major League Soccer stadium in Utah that went solar with REC. These are all interesting cases across the board that really are a testament to how customers view our product, and I hope you feel the same way. So Hannah, hopefully we still have a bit of time if any questions have surfaced.
Yes, we do, and we've got some really great questions that came in over the course of the presentation. So thank you, Chris and George. We'll start off our Q&A session now. Just a quick reminder, you can submit your questions through that questions box on the right-hand side of your screen. And also, if you do leave the webinar, remember to complete that survey, and I'll send you a copy of the slides. All right, we'll get started. So our first question here from one of our dealers. I've been highlighting REC's position on the sbtc.org score sheet as an important reflection of REC's core values. Will you be continuing to participate in the survey for 2016 and onward?
That is an excellent question. I'm going to defer to George on this one because this was a hot topic in Northern California, I want to say a couple years ago, and somewhat seemed to have fallen off the radar. So I'm glad it's resurfaced. I personally, this is Chris speaking, I don't know our position, but George, you may.
Yeah, so this is George. So that's actually run out of it's a global products group is in charge of this, and they did participate this year. So SBTC they came in very strong, and there was a lot of manufacturers that did utilize that service and the feedback. It's kind of dropped out of the limelight. It's being picked back up again. So yeah, we look forward to seeing what the results are this year.
All right, great, thank you. The next question, where do you see the future of module manufacturing in the context of rapid shutdown requirements?
Absolutely. I'll take that one, Chris. So in context of NEC Article 690.12, we will be ready to meet that. So there's a couple of different solutions out there with respect to rapid shutdown. You can do, so the solutions that are in place right now are pretty clear. Most of them are tied in with module optimization, such as your Solar Edge or your Maxim product. However, that may be overkill for specifically meeting the requirements of 690.12. So what we are expecting to have by early 2018, some solutions that are less do not have all the features of a module optimization package. It is not expected that module rapid shutdown will become a requirement until January of 2019, so we have a little bit of runway to see what the market is looking for. But right now, what we're hearing from the market is that they're looking for an inexpensive solution, and that optimization may be a little bit overkill for something like this. I would love to hear the ideas from this group here, what they're thinking they need, what they would like to see to meet feature-wise. Are they looking for a cafeteria option where something would be an optimizer with this shutdown capability, or if they're looking for just the bare bones? We need to meet this specification, and we need something simple and inexpensive and easy to deploy. Any comments, we would really like to hear those, because right now is the time to get that feedback into the manufacturers.
Great. So if anyone does have any feedback, feel free to submit them through that questions box, and we'll be sure to pass them on. All right, and our next question, do you have AC modules in your product roadmap?
We do. We have developed an AC module, a smart module. The problem with that is that it's not something we have turned on. We can't really turn that on. We've developed it, we've tested it, we've certified it, but there's not a whole lot of demand for that right now. And typically what you have to have is a large demand for a product for them to change the line over to manufacturing that product. So I think the biggest concern with that is that there's still discrete solutions out there where you can take a regular module and just bolt an optimizer or onto it, and it becomes an AC module. You can do that, so it allows the installers and dealers to be more flexible with their SKUs. So to answer the question, yes, we have that. No, it's not being offered at the current time. We're waiting for demand to ramp up for that. Or if somebody wants to sign up for probably be at about 110 megawatt annual commitment, we're happy to put that in your warehouse.
Great, thanks, George. The next question we have goes back to the degradation slide. You listed the degradation as 0.48%, and they're wondering if that's the average of 25 years, or is it 2.5% the first year and then 0.48% for the average of 24 years?
That's a very good question. So what that is, that's actual annual degradation starting from year one. So that's measured at degradation from the field. So we're showing that over that first 6 years, we're showing an annual degradation rate of about 0.48 per year. We're not showing the step function there. And we'd expect that to probably continue for, I mean, there's the degradation rate for the ones that we've been studying is pretty consistent year over year. So we're not expecting it to drop off, at 10 years or something like that. So we feel this will probably carry on. This rate will continue on for the lifetime of the modules of the warranted period.
Okay. Another question about the clients you listed in the later slides, specifically about the U.S. Army and Marines. Our dealers wondering, most if not all those installs require American-made modules. How did REC partner with them?
That's a great question.
Chris,
I can handle that one.
Okay.
Yeah, absolutely. So those projects all reference the Buy American Act, but the individual contracting officer allowed for an exemption through TAA, which is a Trade Agreements Act. Singapore is one of the countries, I'd say relatively few, if you look at the major manufacturing centers for PV modules. But Singapore is one of the few that does have a valid free trade agreement with the U.S. federal government. So not only relevant to that's how we were able to get in. It's basically BAA compliance through TAA exemption. Does it work 100% of the time? No. But a lot of the times it does, and it is a lot up to the contracting officer. And if you want a greater degree of information on how that actually worked out in those cases, George is a great resource for that. But I would also use this as an opportunity to highlight the fact that Singapore's relations with the U.S. government are tighter than really any other Asian nation. And it's because we both started out as British colonies. There's, our governments have a lot the same pro-business mentality. So if there were trade barriers and trade challenges, there's one that's arising right now out of the Suniva bankruptcy. There's always an excellent chance that Singapore will be treated much better than any of the other Asian nations. So another reason to be watchful and keep your eyes on REC.
All right, and we'll move on to our final question. They'd like to see a comparison to Mitsubishi panels. How would they compare?
It's a great question because I'm personally a big fan of Mitsubishi Electric. A lot of their product line, not just the modules. And when I was literally in home selling residential systems a decade ago, I sold a lot of Mitsubishi 185, and it was a great product. That particular company, I'd say there's some similar DNA. They actually designed and produced a half-cut cell product. They had some commercialization issues. They could never make it into mass production, but they actually did that before we did. I think this is an excellent follow-up topic for later because we'll want to dive into specific details, as in what elements of the product. Is it degradation rates for LID and annual? Is it an energy yield comparison in what particular type of installation? Is it compatibility with racking or mechanical loading or dynamic mechanical load performance? There's a lot of areas that we can dive into. And again, I feel that the REC comparison will be quite favorable even against a highly regarded competitor such as Mitsubishi Electric, but we would need a little bit more information about what exact units we're comparing and in what specific circumstances.
All right, well, that wraps up our questions for today. Thank you, Chris and George, for answering those, and thank you, everyone, for submitting such great questions.
Likewise. Well, thank you, Hannah, for being an excellent moderator here, and to everyone who's still on the line about to drop off. Enjoy your weekend, and hopefully those of you in the Midwest and the South are be okay with this weather that's showing up. But definitely look forward to having more and more REC business through AEE and interacting with the dealer base and finding new ways that we can all add value to each other. So thank you so much for that.
All right, and remember, you can contact your AEE sales rep for more information or to get a quote going for REC panels. If you're not sure who your rep is, feel free to contact me or anyone else from AEE, and we'll be happy to help direct you in the right direction. And just another reminder to complete that survey so I can send you a copy of the slides. And we'll also be posting this presentation on our YouTube channel, AEE Solar. So if there's anyone who missed the presentation on your team or you'd like to go back and watch again, it should be up there later today. And thank you again for joining us today, and have a great weekend, everyone.
Thanks a lot, Hannah. Goodbye.